Concepts build clarity. If you have a clear mind, if you study well, then definitely you will have less confusion and you will build confidence. Once you build confidence, it will help you to appear the exam, to clear the interview. Also, on the job roles, you will be able to work on daily basis in the right frame of mind. Your life will be easier and comfortable. So building confidence is very important. For that, you need clarity in mind. If you want to develop clarity, whatever you study, you need to go to the base level. Once you are fine with the base level, then you can go to the advanced level. Because hypothesis testing is very, very important. It will be a very, very easy example. Even a 12th class student or 10th class student will be able to understand. Today, I'll take you through the concepts only through one example. I welcome all of you, those who are studying actual science, data science, or statistics, or any subject related to hypothesis testing. Let's get started. You got a chance to enter this classroom. You visited a school, the students, they're studying, and you have been invited as a guest faculty. Something came to your mind. You recently studied hypothesis testing. You wanted to apply the concepts already you developed here. You want to test yourself whether you know the concepts well or not. So definitely a question will come to mind. Can you apply a hypothesis testing here? So let's start thinking. The first question will come to anyone's mind. How many students are here? First count the number of students here. This is a classroom. Let me write. This is the name of the school. This is NPSP school. This is the name of the school. And you are in one classroom. That means you can consider this as a sample. Now, first of all, you observe there are 14 students in total. Let me write N. N is 14, 1, 4. The number of students. And you saw the number of boys here and simultaneously the number of girls here. So if you count the number of boys here, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. So let me write the number of boys and number of girls, 6. Now, what is the first question that will come to your mind? Definitely you start thinking whether the ratio of boys and girls in the school they are same or not. That should be the first question. So if you think that whether the number of boys and number of girls in the school they are same or not, can you test it with these classroom students? What test you will apply? Because you know t-test here. Let me write one by one. You know here t-test. Can you apply a t-test? This is again one sample, two sample, one sample, two sample. Let me write this way. One sample, two sample. We have z-test, one sample, two sample. We have f-test, one sample, two sample. We have chi-square goodness of fit test also, or test of independence. Let me write test of independence. We have binomial and Poisson. Binomial and Poisson. So if you are interested in the proportion, you want to know whether the number of boys and the number of girls, their proportions are same or not. That means you are interested in P here. It's a binomial case. Again, you need to decide whether you want to test for continuous one or discrete one. We are taking a discrete one here. You can take binomial. That is the only option here. So I'll go with my hypothesis. My hypothesis H naught. H naught. So I have only two alternatives. Either I will reject H naught or I will not be able to reject. These are the only two alternatives. So H naught you write whatever you want. Suppose I will write P is equal to 0.5. I want to know whether not in the classroom. In the classroom we can see in our eyes. We are talking about the school as a whole. Whether in the school, suppose there are 20,000 students. So if you think the school as a whole, that is our population distribution. We are talking about the proportion here. So whether the proportions are same or not, that is what we want to check here. So quickly, I will take you through what we do in hypothesis test. I'll take 1 or 2 minutes, but before that, let me write the alternative hypothesis. Again, you need to think whether you need to take greater than or less than or not equal to. Let me take not equal to, because I want to know whether 50% boys, 50% girls, they study in this particular school or not. You are in a classroom randomly and you got a sample. With the basis of this sample, you want to give a statistical inference. This is called classical statistical inference. We are Bayesian also, but yes, we are now doing hypothesis testing. So I'll give you a brief introduction. This is going to help you. So this is our population. This is a sample. This is your whole school, and you have taken a sample. From the sample, what you can do is you talk about height, weight, IQ, whatever you say. In this example, probably I've taken something different. Number of boys, number of girls, right? Proportion. That's why that's discrete. But normally when we go to T test, Z test, we'll take continuous. Again, let me tell you, the students in a class is not population. Population means you have to say something like their marks, IQ, their heights, weights, right? Anyway, you will get it. So what normally we do is we find the simple statistic at CS1 level. Normally we do for X bar, two statistic we take, not more, and H square. That's all. Simple statistic we find from the sample. And on the basis of sample, we try to say something about the population parameter. Population parameter, that is mu. The first one, we want to say something about mu. We want to say something about sigma square on the basis of this. So there might be error. That's where we study type 1 and type 2 errors. That's a separate thing. I'm not going to that now. But yes, on the basis of sample, we want to give some inference for mu and sigma square. So what are the chapters dedicated for this? We have one chapter, one of the chapter we'll do today, but we have other as well. You can find a confidence interval, you can point estimate, okay? So point estimation, confidence interval estimation, MLE, hypothesis testing, all this. I mean, this way we'll be able to say something about the whole from the sample. Today, I want to do hypothesis testing. If you want to know in details, you can watch my full video. I will give you in the link. Now see, here we started with this one. We'll apply a binomial just because this is discrete. We are checking proportion. And when you are checking proportion, you have to test this. Also, you need to know now whether can you write the first line less than or equal to? That is also something you need to check. Okay. What is the meaning of that? But anyway, it's not required at CS1 level. If you have any doubt, let me know. Whatever concepts you are doing, your mind should be very clear. Anyway, now we are checking. This is a two-sided test. So for the test, I will not do as I already mentioned you. I'll just let you know what you need to apply, what test. Now this one also, I'll give you, see how you can do one sample binomial. Okay. So under H naught, what we do is we accept, here I've written, under H naught, P is 0.5, P is not 0.5. Under H naught, all the time we check like this. Under H naught, that means we assume H naught and find the test statistic whose distribution we know, approximately normal, but n is not very large, n is 14. However, in binomial, we check whether NP is greater than 5, NQ is greater than 5 or not. Here P we have taken 0.5. This is N is 14 and P is 0.5. So NP is 7. Okay, so 7 is greater than 5. So there won't be any problem. You can still apply. So this is our test statistic. Otherwise, you can do directly as well. You must have studied in confidence interval. How can you do it directly without using central limit theorem? So whenever you are testing a hypothesis, you must know the test statistic distribution. If you are finding a confidence interval, you must know the pivotal quantity. That is the difference. So now here, this is what we are checking, equal to, not equal to, and under H naught, you find the value of this. Okay. Whatever I've written here, the same thing I've written here. This should follow normal. So if you find its value, I got 0.276. Okay. And then whatever probability, whatever way you want to do, you can do two-sided. It's a two-sided one, not equal to, so I multiplied by 2. So I got the 79% is our p-value. Both sides, if you count this way, 79%, almost 80% p-value. That means, can you understand? 80%, 79%. So at a 5% level of significance, 5% will come here. So 5% is here, level of significance. Okay, this is my level of significance, 5%. This is 5%. This is level of significance. Then test statistic. I mean, if you are finding, I mean, I didn't find the value of this. We found here P p-value. So if you are using p-value, it's 79, 80%, I mean two-sided. So 40, 40 you can take. It will come somewhere here. You see the conclusion. We have insufficient evidence to reject H naught. The wording you have to know. Sometimes we write we accept, but how can you accept? We reject a hypothesis or we are unable to reject. Here, insufficient evidence to reject. We cannot reject. I mean, you can say roughly accept, which is not true, but yeah, that you can say. There is insufficient evidence to reject this one. That means you are accepting. Okay, what we are accepting? Proportions are equal. Okay, so what will happen is when you are accepting, that should be in the acceptance region. I found the p-value. P-value, how can you do is up to p-value, it will be accepted. Means up to 40% one-sided, it will be accepted. Otherwise, it will not be accepted. That's all. It's 5%. So directly I can write this is 5% because this is 5%, one-sided around 40. 39.5. Okay, here 39.5. Up to that you will accept. So at a level of significance, 5% you are unable to reject the hypothesis H naught. Then 10%, 20%, at 20% also you are accepting H naught. Okay, again I'm saying, remember, not rejecting means you are saying accepting. Now we'll go to the next one. Now let me erase all and we'll try to know whether we can apply T or Z distribution. Definitely not when you talk about the number of students. Again, we are not talking about the classroom. We are talking about the school as a whole, that is population, the distribution, the proportion of students in the whole school, NPSP school. So that is statistical inference. Suppose you will write somewhere, you write an article, you don't say that in the classroom uh, we are unable to reject H naught, P is 0.5. So proportions are equal. You don't say like this. You say about the school. You should not say what technique you used, what kind of sample you took. That's your private thing. Okay. So we are talking about, we are giving inference about something for the whole population. Now, the discrete part is over. Let's go to the continuous one. Can we apply a T distribution? Now we'll see whether we can apply a Z distribution, Z distribution, or T distribution. Acha. First of all, if you don't want to go to the principal, even if you go to the principal, if he says something about the IQ of the students, the whole school, if he gives information, then only you can go for a Z test or G test. Okay. Otherwise, you can't because you need sigma, the standard deviation. What kind of standard deviation? Let me write here. If you know the standard deviation for the whole school, okay, because the school, they've experienced, they know since last 20, 30, 40 years maybe. So they know the kind of students, their IQs. So they will be able to say the population standard deviation among what? Whatever we are saying, suppose IQ. So if they can say the IQ, they know that, okay, most of the students, they are of equal IQ and it will vary by only sigma square by 20, I mean 5, you can take 4, 2. If you know this by chance, then only you will be able to use a Z test, okay? But you don't want to visit the principal, you don't want to get this value, only on the basis of sample you want to do, that's fine, okay? Again, you need to divide boys and girls or not, that is something you need to think. So you have choices, okay? You can take only boys and you can check their IQ. You can take only girls, you can check their IQ. You can combine also. There won't be any problem because we're checking IQ, not height or weight. Okay, so I combine everything. I'll take N14 once again. Let me write. I will take, I don't know sigma. Okay, I don't know standard deviation. Standard deviation is not known. So I'll go for a T test, not known, because I don't want to visit the principal of the school and ask details. Even if you go, there is no guarantee that they have a record because we are talking about the standard deviation. All students, even we'll do a test in today's class. We do ourselves, okay? But we'll go to that later. We'll use app test. Now my hypothesis is H naught and then H1, okay? So what I can do is either I will take all the students, I will take a test Okay. So I will see the IQ CBT test. It might take 10 minutes time. I will give 10 or 15 questions. Let them do the questions, multiple choice question. Immediately I will be able to know IQ test. Now let me check what is here. If I check here, one simple normal distribution, there is an assumption also here. I will go to that. So we're using this one. We are using this sigma square means for the whole school, the standard deviation, the variance is not known. Okay, so we'll use this one. T distribution here instead of normal distribution. But here the assumption, you remember, the assumption, the population is normal anyway. Population is normal. All the problems we will do today, population will be normal apart from binomial and portion. Everywhere population is normal. Population normal means what? Suppose I am checking IQ, there should be little variation. Okay, most of their IQ should be around a particular number, suppose 100. Okay, all should be like 100, 98, 99. That way, I mean, that way it will be normal, right? What will happen? Most of the students' IQ will be 100. Suppose you have, I'm talking about the whole school, 20,000 students. Probably this, if this is the frequency, 10,000 students number that will come here, and another 8,000 will come here. So all will be between 1990 to 101. Okay, and little some 5-3 students IQ will be 80, 110, like that. So what will happen is it will be normal structure. Okay, you understand what is the meaning of normal distribution? Normal means many will be around the center. 100 IQ, there will be around out of 20,000 students, you take 10,000 students. Suppose I'm saying, I mean, every point that will come, it's a continuous one, right? Not exact 100, probably 101 you will get some, 102 you will get some, right? That way you will get here. Okay, most of the students IQ, they should be around a number. The extremes should be very low. That way what will happen, it will follow normal distribution. So that is the assumption here, then only we can apply this one. Now what we have done here, we are checking whether mu is 156. Oh god, 156 mu in India. Is it? Are we talking about IQ? I think we are talking about heights. Okay, no problem. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm changing this one. Now I'm talking about the height of the boys. Okay, H naught, mean height. So here, what is our assumption? Let me write my assumption. Height of the students, not in the classroom. Height of the students in the school follows a normal distribution. Height of the students in school follows normal distribution. In that case, what will happen? We'll be able to apply T distribution. Okay, so we have to check heights. So checking heights, it's very easy, right? We don't need to go to anyone. So directly we'll check the heights. And I've written here 150, 150 what? 150 5 feet, 150 centimeter, 156, 152, 155, 160, 153, 157, 151. That way, 8 boys are there. I'm talking about only boys here. We're checking for boys. Okay. You give rest to the girls here. Let them be busy with their mobile. No problem. So here I got my X bar 154.25. X bar is 154.25. Okay. 154.25. I got X bar 154.25. On the basis of this, and also we need here not only X bar, we need here another one, S square 10.21. We need these two. So using these two, you will be able to test the hypothesis whether this is equal to 156 or mu is greater than or not equal to what we are checking here. We are checking here mu less than 156. Okay, we're checking whether mu is equal or less. This is, we're talking about the height of the boys in the whole school, that is mu. Height of the sample in this class, we have taken 8 students and we have collected the data, and then we took the sample mean, sample variance. Using those, you see, this one is here. and I explained all in previous classes. Okay, so you find a square, all that, whatever way you accept or reject. Okay, so what we are doing here, we have insufficient evidence to reject H naught. That means kind of accepting. This is done. Now we'll go to two sample. Again, this part we are leaving. We will be using this one. So now here we are checking. Now we'll take two population. So when you consider two population, what will happen? Here we have two population. You see, mu boys, mu girls, they're equal, or boys is greater than girls. That means we've taken two samples. Okay, where I've written two sample. Yes, sample means we found here. Let me write this. So we have taken boys here. Now we have taken boys height and girls height. How many boys are there? Mn we have taken. You can take N1, N2. Okay. M is 8, number of boys. N is 6. And you write all the heights here. 8 heights, 6 heights here. And you find the mean. You find the mean here. And you find the standard deviation of boys heights, standard deviation of girls heights. Okay. Then you find SP square, pooled variance, pooled sample variance. That way you test it. Okay. Again, I've written here how to do. I taught also already. You follow this one. This is given. So what is the final one? Here it's given. We have insufficient evidence to reject H naught. Again, we're accepting. What we are accepting? The heights of boys and girls, there is no difference. Okay. Insufficient evidence to reject H naught, because in H naught we have written mg mb is equal to mg. Mb is what? The boy's height, mean boy's height for the whole school, and mean boy girl's height for the whole school. Okay, we are saying this. Done. Now the next one is one sample normal distribution. We are checking about the variance here. Okay, we are checking the variance. The variance is 3 or not 3. What is the meaning of variance here? Now again, we are talking about what? Heights data, heights again. Okay, no problem. So you consider the heights of what? What is n here? N is, we have taken n is 8. That means again we are considering boys. So we want to know boys heights variation, we want to know. Variance. That's where we are checking for sigma, standard deviation. Whether the standard deviation among the height of the boys is still in height now. Okay. So if you see the standard deviation is very low, suppose 1, I will write. I mean, this for boys. For girls, I will write this. So if you see the heights here, I'm not interested in the heights, variation in heights. See, there is a lot of variation in heights. So what will happen is, you see the height here, see the height here, see the height here, see the height here. Here probably sigma 1 is 1, sigma 2 is 3. So they are not same. But can you see this kind of students normally? I mean, little if you see in 2 or 3 students, that's fine. So you are checking whether they are equal or not. So what we do is we find this value sigma 1, sigma 1 by sigma 2. We see the ratio. If there is a chance in confidence interval, we see whether you get 1 here or not. In hypothesis test, whether we see they're almost equal or not. That way, if this is near to 1, less than 1, greater than 1, it will depend, right? What you are getting here. So in confidence interval, in hypothesis test also, we check whether they're equal or not by ratio test. In t-test, what we do? T1, T2, difference we find normally. Okay. This is difference we find, this is ratio we find. If difference is 0, then they are equal. I mean, mu's actually, using t-test, mu1, mu2, mu1 is equal to mu2 or not. That way we know using t-test, using sigma test actually for 2, we check ratio. Okay, why? Because that's how the results are available. Okay, done. Acha. Now there is another one, before after. Okay, suppose I want to use a paired t-test. That means before after experiment. Before after, what you can do? You do one thing, you check the IQ of the students. You combine all the students because you are interested in IQ now, not height or weights. So you combine all students. N is 14 here. Let me write. N is 14 and I want to check the IQ. I will check the IQ of all 14. Okay. I will get IQs like this. 101, whatever. Let me write 1 here. 102. And the last one, I got IQ 104. All 14 students. Then this is before giving a class. Then I gave a class for 2 hours on different questions. I gave them practice questions. I prepared them. Then I checked once again the IQ. So now I want to see whether there is a difference or not. In this case, there is a dependency between this and this. Before after experiment, you give medicine, BP medicine, you check whether BP reduce or not. Thereby you will be able to know whether you can apply this BP medicine to all the people or not. Okay, if it's a new drug. Effectiveness of a medicine, that you, before after. So here they are dependent. The samples, we say there is a dependency. Okay, that is they're independent. Okay. In the former case, we use the samples are independent. When you find SP pooled variance, they're independent. They're considered. They are two different groups. There is no difference. In that's why there is a concept of N1, N2. Here, there is no concept of N1, N2. N they must be the same. Okay. So remember what we accept, the normality of the population, that's always there, and the independent of the sample. In the previous case, when you apply two sample t-test, and here before after experiment, sample dependent. So NN on the same control group or on the same people, you apply the test once again after giving a training, giving a medicine, giving, I mean, some kind of measures you can do, and you will be able to know the effectiveness of that program. It could be training, it could be medicine, it could be whatever. I mean, there are thousands. Okay. So again, you know, how can you do a paired t-test? See, this is before and this is after the data. You can collect yourself in the classroom, and then you find the differences. It's a t-distribution. Again, we don't know standard deviation. So you check, you use the standard deviation. It's, I mean, wherever AC is there, you can use T, right? T value, it's estimate. So you find all this estimate, and then you can use this one. Again, you can accept insufficient with sufficient evidence to reject H naught at 5% level. So that means your program worked. Before after means what? Whatever training program I gave to the students that helped them to achieve more marks, because H naught is rejected. Sufficient evidence to reject H naught. So H naught is rejected means what? Their equal is rejected. That means they're not greater. I mean, A is greater than B. Now we'll go to, this is the last one probably. Yeah. We see whether we can apply any contingency table, chi-square contingency table, if you know. Whether we can apply that kind of a test here or not. So for that, we need to go to different rooms. We want to know whether the proportion of boys and girls, they are same or not. So we'll go to another one. This is another classroom. So now we have two. This is a classroom and this is another classroom. You combine both the classroom students, boys and girls. Now, what will happen? You want to know about them. So what you want to know actually? It's not binomial like I started. Let me go to the table here. So if you go to this table, in class 1, we have the boys and the girls. There is a distribution of distribution could be 50%. I mean, half boys and girls, they're equal, or maybe boys are more. I mean, some proportion. Okay. So there is a proportion. It's not that randomly boys and girls they are sitting. Suppose this is CS1 class, this is CM1 class. Okay. So when students they start, suppose many they start with CS1, Many girls, they are interested to start with CS1, whereas many boys, they want to start with CM1. So what will happen? Even if the number of students they came to the school in equal numbers, I mean, in the classroom, they will sit differently, right? That is what you need to know. So even if they came in equal numbers, but they will sit differently. So you want to know whether they are dependent or independent, whether the proportions they are same or not. That's where we check independence. Okay. We have a question. When you check independence here, uh, you use a car belt, and without using car belt, you drive a car and you check how many people died here. This is car belt. Okay, so suppose 20 people died. Here 80 people died. There is a clear link, right? Car belt. You can see the injury also. Suppose here car belt, sitting car belt, more injury. Okay. Here less injury without sitting because you can run away, right? 5 or 10, something like that. So you know that, okay, I mean, there is a dependency wearing a seat belt. Okay, that's what you need. I mean, you are doing in contingency table. You are checking whether there is a link or not, they're dependent or not. If you go through H0, H1, you will be able to know formally gender is independent of classroom, gender is not independent of classroom. So you find this one, then you find the total, whatever way you do. Finally, you decide this is significant or not, because when they are close, the number should be very low. How can you know it's very low or not? There is a standard. Okay, in the table it's given, then you decide. So what is our conclusion? There is no significant evidence that gender distribution differs. Okay. That's what you are doing here. So this is what I wanted to teach in today's class. It's a kind of introduction to hypothesis testing. You have to do in details because this is very, very important. Definitely, I will come back soon with a new concept. For today, class is over. Thank you.